Hi. So we had a pretty good week this week. Had a pretty good turnout on Saturday. We got a lot of progress in, especially adding a lot of the structural elements of our robot. As you can see here, we have actually basically most of the robot done. In terms of fitting it, there's still a lot more detail that needs to be had. A lot of hardware needs to be switched, but this was just a check to make sure that everything fits how we expected it to. Like we added these support bars for this cardboard funnel. We tested the algae intake with the long belt run and confirmed that yes, the ball does fit. We switched to 2-inch wheels because we didn't see a point in doing 4-inch. We could do 3-inch, but two is working fine for now, so probably won't touch it. And you can see here we did assemble the everybot climber. It feels pretty good, and yeah, it fits in the robot pretty well. Uh, and then on the elevator, we also added a temporary little visual here for the cable chain, I guess you can say. This is where we would run all of our wires for the arm here. So CAN bus, power, and all that. And then in terms of the actual CAD, we haven't really changed much. Um, one of the things I did change was, or one of the things I realized last night was I redesigned this pivot plate from the original one, and the original one had belt interference. This churro here on both sides would interfere with the belt, and so I made them further apart. But one thing I didn't realize was that they restricted the motion of the arm too much. So these ones are a lot better. The arm should be able to go to 90 degrees up and down now, which is unfortunate that we already cut them, but future iterations would have the correct version. I also, since I think we finally decided on just doing a live axle here, so uh, yeah, I just updated the arm to to show an live axle may look like. I'm pretty sure we use a different hub here, but it's not critical right now, so I won't worry too much about that. And I think in terms of the CAD, that's all that's changed. Or one other thing is the way we're gonna do battery and the breaker. If this is load, we decided to. Right now, we just have this front plate that covers the battery part, but we're probably gonna swap the inside plate and maybe the outside plate to include this. It should be clear, so it shouldn't be an issue too much with the rules. And so this way, the breaker is nice and close to the battery, and the battery wire should be easy to bring over. I think that's it. And other things that I need to still CAD, I think right now it's just a matter of adding a lot of detail, just to make sure that all of the little stuff fits. So I need to figure out more in detail how we're gonna do the cable stuff, how we're gonna mount this, how we're actually gonna mount this to the drivetrain, and also another thing that I would like to do is start thinking about like software wise what sensors we would need, like any encoders that we need, limit switches and all that stuff. I would like to add that into CAD just so we're clear about it. And then another big thing that I haven't explored enough is how we're gonna actuate this funnel. Right now, I just put a sprocket in there, but that's extremely old, and we have talked about maybe just making this funnel spring loaded to where we just release the spring at the end of the match, and so we would only need it once a match at the very end. But yeah, that's still very undecided. We're gonna decide on it hopefully by the end of this week. My goal is to have the CAD like fully done, basically frozen within the next week or two. It would be great if we could do it if I could do it by this Saturday, but I don't think that's gonna happen. Uh, there's just still so many little details that I need to add. But yeah, we did make a lot of progress in person, so very promising stuff. I think that's it. You're muted. Oh, okay.
Let's talk about the arm. So it was pretty flexible. If we added something to stiffen up the arm at the top, would we have room to do that for the algae arm?
For the algae arm, this one.
Yeah. Like if we added a churro that went across somewhere above the wheels, do we have room to do something like that?
I don't think we would, because up here. Yeah, I don't know if we would, because we would run into here. I mean, is it too flexible? I mean, we can always. I think if we add the standoffs that I have in there, because right now we have like two on each side, three on each side. But if we just add more standoffs, I think we should be okay in terms of the flexibility part of it.
If it's only driven from one side, you're going to have problems.
Yeah.
What about switching to box tube? Since we're going to be
Instead of the
making a box here.
instead of the polycarb plates.
Yeah.
I mean, we could what like just make it out of max pattern or just like just any tube that we find. Just any tube.
Yeah, it could be max or it could be just a tube that we make holes that match up to these dimensions. Like a clean 2x1.
Yeah. We could do that, but then I guess the one downside to that is we're going from too much flexibility to no flexibility. But yeah, could be easier in the long run. I just haven't thought about doing box tube that much and how or what that would look like.
So what Carl was alluding to is driving the shaft on both sides. Does it make sense to run a shaft through there? I don't know how much that's going to conflict.
Through like down here or through the top?
You could run a shaft all the way through and just put a belt on the other side as well.
Yeah.
I don't know how that would fit with the ball though.
And that gives our motors down there a little bit more protection from the balls coming in.
Yeah.
So it might be worth just throwing that shaft all the way across and then looking at some sizing to see if that makes sense.
Mm-hmm.
Let's talk about the funnel. So if we're going to make a real version of this, we've got angle, that's a plate, so we could laser cut a lot of stuff here pretty quickly and just assemble a version together. Are we making this thing too wide maybe? Should we be making it more narrow as it gets
Um,
like it's
I
like basically um, make it funnel down faster? What was the did you just copy Rust Sounds geometry or how?
Yeah, this is very similar to theirs. I think our this one is a little bit because of how the funnel would interact with the drive bracing and the space that I had. I think this is a little bit thinner, or I think a good amount. Not it's not as wide, but yeah, like the main dimensions I focused on was like um, the dimension width up here and the width down here, and then I just threw in an angle that I estimated that looked fine.
I don't remember what our bed size is, but if we cut this triangle piece in the laser, I don't know if it'll fit. And it looks like it's going to have some instabilities here. Is that cutout too big?
This one, well, this was adapted for the 4-inch version. I haven't really changed it for like a 2-inch. A 2-inch you would need a much smaller cutout, but yeah, like the cutout would only go to like maybe this hole, maybe even less.
Okay.
So
I
between
think
here,
this is a part we should definitely prime for Tuesday laser cut out of like wood, because I know we've been having some issues with acrylic, and
hmm,
we could quickly just test how this works pretty easily, I think. Even if we make some quick and dirty, well, let's talk about these. What other? I guess there's a pivot plate, so it's actually those side plates are kind of important to do right. Um,
these ones,
yeah, because there's an actual bearing hole in them, right?
yeah, I think one of them should be a hub. Yeah, one of them should definitely be a hub, but I threw that together quickly, so
So you
I'll
mean
need to
you
change
need some
that.
holes for a hub? Is what you're saying?
Yeah, yeah,
Okay. Yeah, I'm not even really worried about the angle side plates because those are just pieces of plastic, right? We could just, I mean, if we cut them, great. It makes it a little faster, but the uh, the ones with the pivot, that's actual geometry we need to kind of get right. So
yeah,
we need to make sure those are done well. We could even have just little, quick cardboard or just temporary
yeah.
flaps on the
Like
side there,
like
real quick, just to kind of make things work.
yeah, like these can be like anything for now. It's not
Okay.
it's not critical.
Yeah, we obviously need to test this and make sure we are happy with how it fits. And then I think you need to do some major work on the static portion of the funnel
Yeah.
and really make that much smaller and minimal because it's sticking out pretty far. It's like overkill. Like think about it if you did it the exact same way where you have those metal angles, that um, support beam, I think it only needs to get to like where your
And
angle bars would be. It doesn't need to go anywhere near as high as it is right now.
yeah.
So you could chop off, for me, it looks like almost 6 holes off the top of that pretty easily and still have enough to mount stuff to.
Yeah.
And maybe we don't want that so close. You need to kind of look at some pictures of how the winch is set up because that winch is pretty tight. I mean, it's coming right through there, and we might want to think carefully about how we do this. I guess you got a shaft coming on the other side though, so it's all real tight. So, yeah, you might want to mock up like some sort of string from the winch to the climber, so
Yeah.
you can see the conflict when it is coming. Because there'll basically be something coming all the way down to the winch there.
Yeah.
And then once the climber pulls in, you still don't have something for the cage to hit into.
Yeah.
So we might want to also incorporate with the static funnel, thinking about what is that going to be, and is it going to attach to the static funnel, and maybe we need to think about making it stronger so it can handle that load.
Hmm. Yeah. I think the way the everybot has it, it's just like a piece of it's just a piece of or a couple pieces of tube, right? That the cage just hits.
Yeah, yeah, it's just a hard stop, so it's just a piece of metal. So I think you might want to just put the cage and put it in your model, pull it back, see where the cage you think should stop, and then have something that actually stops the cage close to the top, I think is how it works. Because you've got a hard stop at the bottom, but as the cage folds in, you have nothing that stops it as it keeps
Yeah.
folding in, right?
Yeah.
It's eventually going to put, I mean, I guess the hinge will stop eventually, or no, I don't know if it'll really stop. I think we could pull the climber until you start breaking stuff. I think is how it works.
Hmm.
Yeah, so we gotta think carefully about that because it could destroy itself.
Probably want limit switches.
Yeah, I
Yeah.
think we definitely need a switch to trigger. But I think we need to have something to mount the switch to, so when it hits, I don't know. It's something we're gonna need to test. It's gonna be a little tricky, I think, to get all that right in CAD. So, anybody else? Any other big things?
Um, I saw on I saw yesterday that when the inner stage was pulled up on the elevator, there was a lot of slop as it got to the top. Was that like why? Do you know? Do we know why that was happening? Is it too wide or something?
It's too wide at the top.
I think there's a slight stack up of manufacturing gaps. So this brace piece needs to be extremely rigid.
Okay.
So I've been thinking about it. I need to draw up something decent that we can talk about. But
Yeah, build quality is tricky sometimes on these elevator parts. So we're gonna have to really just make sure we build it in the most reliable way and if it doesn't slide well without any motors on it, we got to fix it because once you put the motors, it's just going to get worse. So, we also need to think about putting the lift motors into those beams, and we need to decide between max pattern or grid pattern.
Hmm.
If we want to attempt max pattern, you might want to just throw like a max pattern in there real quick just to kind of
Yeah.
see if it fits nicely. If it doesn't, we might want to just not even think about it anymore.
Hmm.
And then we'll just have to take those beams out and drill a really accurate hole. Or not accurate, but at least straight, big enough to put those plates through and mount the motor shaft. I guess technically it's just big enough for
It's just a bearing hole.
yeah, bearing hole. But the plates themselves are the bearing hole. So it's actually kind of interesting. Maybe we don't have to be very precise. I don't know.
You just need a minimum to be a bearing hole, but it can be bigger. So if you want more clearance.
But same goes for all the stuff we want to run through there, right? Like if we're going to make any more holes or anything, like if we need holes for wires to go through, once we take those bars off, the inner drive rails, we need to have a plan to do all those things at once before we put them back on.
Hmm.
So any holes, any things we want to drill through, we should start thinking about all those things. So it might not be a bad idea to not only put things like cylinders coming off the battery switch, but that would act as like wires. But start thinking about like how are the wires going to get to like let's say the node modules. Are we going to run them over the support rails, or are we going to have a hole that they're going to go through those inner drive rails to get to the power distribution board?
Yeah.
My vote is to not run them over the drive rails.
Yeah, that makes sense. So you're saying like all the corners, just add like a small hole that we can run the wire through.
Now, if we
So
go to max tube, they have plenty of holes already thought out.
yeah, and we wouldn't need to.
So it might be worth the experiment to look to see, do we want to change to max tube? And if we do, will it fit nicely with our lift? Because it doesn't always, like looking at how the funnel max tube worked out, we did a pretty strange extension to make it fit in dimension.
Yeah.
I mean, we could do something like that, but it looks pretty strange. So we need to think about it if we're going to make that cut.
Yeah, we may need more max tube. There's
I sized out two
okay,
max tubes
two.
that should have the length. So as long as
Okay.
nobody uses max tube,
Yeah.
I think we have just enough. But
To switch the drive
or we
bracing
need to
to.
order more. Yes, I will order more.
And also, I realized for this climber motor, maybe I got something wrong in the CAD, but it looks like it's missing a lot of components that I didn't see. Like it's missing the whole pulley assembly as well.
Yeah, that spool is a bit bigger than it looks. Um, so if
So
you want to
I'll
look at the
need to add
picture that
that.
we have there, I mean, there's a spool, there's another mounting plate, and
Yeah.
that takes up at least as much room as that gearbox does. Um, so yeah, that needs to be. It doesn't exactly need to be modeled, just kind of a box to show that that's how big it is.
Mhm.
And keep in mind the way we're attaching between the winch support and that cross brace, we need to have access to some of the screws. So I didn't take it all the way over those screws at the very end of that winch motor so we could get access to the screws. Does that make sense?
Well, like the motor, like the screws that come from the bottom here.
Yeah, so if you're looking at the last few holes that connect to the cross brace, I kept those clear. Yeah, that hole right there.
Oh, so we can connect it
So
together.
we can
Yeah, I see.
connect stuff. And so that's pretty close to where the winch stops right now, if I remember right. So if you wanted to draw a box, that would kind of represent how big the winch is right now. It goes all the way to that second hole. I left the first holes open.
Okay.
I'll upload a picture, but it looks like there's two holes, and then the winch is attached. So I'll upload that.
Yeah, maybe it is two. That's true. I might have moved it over a little more. So we could possibly move it over one more hole if we need to. But still, it's bigger. It definitely sticks out further than it's in your model. So.
Yeah. And I remember we had it very close to the actual edge of the drivetrain.
So are you happy with the power distribution board where it's at right now?
I don't know if I'm like happy about it, but I don't know. Not. I don't exactly know where else it would go. Um,
We can always have a separate panel for it that gets mounted somewhere vertically. If you can't get your fingers in to reach those lever nuts, we're
yeah.
going to struggle.
So just like a vertical plate that goes this way, maybe.
Mm-hmm.
It's not a bad idea.
Yeah, one of those mega gussets that holds on the elevator. We could rivet
yeah.
all to that.
Wouldn't it be too far from the battery in that case?
Well, we don't have to have super short power cables, but usually, yeah, the shorter the better.
Okay. Yeah.
Yeah, we need to get that set soon. I guess we can do a little bit of testing with just putting one on there and moving around to make sure we like where it's at. right now, I think the only way you could do some serious work on it is you'd almost have to remove that winch bracket, the whole winch assembly, to really do real work on it. So it is going to cause a headache, I think, if we have to do any serious changes to it.
Can that winch get mounted to one of our transverse rails, like underneath one of those arm motors?
The winch for the climber?
What was the question?
The winch for the climber?
Uh-huh. Yeah, so where the PDB is, can it kind of be tucked on that rail sideways?
It could be. And I haven't really looked at it.
You know, that deletes that extra 2x1 you had in there and maybe gives us a little more belly pan access.
Yeah. Yeah, I could. Yeah, no, that wouldn't work.
So we don't have the brackets modeled, but those brackets actually go beyond a 2x1. So if we did that, I think we need to cut out something, or either cut the brackets down or make holes in the belly pan so the brackets would stick out from the belly pan. You probably should put those brackets into the model.
Yeah, no, I will do that.
Yeah, I think that's going to be one of the major issues, is figuring out, being happy with where the PDB is going to go. Because the sooner we can get to that, the sooner we can kind of put it in and start building it. So it's an important decision. Any other ideas on where we can mount it?
The PDH, I like the vertical plate idea. Just a vertical plate that extends here. I wouldn't. Yeah, I like that idea.
As long as there's no risk of the ball hitting it.
Yeah.
So it would be like almost on the battery. Would it be on the battery plate, or what kind of plate would you?
Probably you would just make like a rectangular plate that attaches to these holes, and then just put it vertically.
Okay, so it would be very close to the battery.
Yeah.
Yeah. You do have room in front of the lift too. I mean, there's nothing underneath.
Yeah.
There's nothing there yet. I mean, you've got the coral can't go down any further, so you've got an empty spot, and it'd probably be nice to have a clear spot versus the high traffic area in the back.
Yeah,
I also haven't looked at the. Yeah. Go ahead.
yeah, it's something to look at, Cedric. I think if you want to put it there too, that whole lift, can easily move up, and then there'll be nothing there. We could do all the work we want to just by moving the lift up.
Yeah. Would the battery need to move to be closer to it, or do we have a battery wire that can go from the battery to the PDH if we were to put it there?
I've got like 10 feet of battery wire waiting to be used.
Okay.
I mean, obviously you would put the battery terminal section of the PDH going to the battery side, but I think you should be okay. You might have to run a hole through the support rail so that you could get directly to the power switch. But other than that, I don't think it's a big deal. So. Yeah, I forgot that we got the cage coming through. So a vertical power distribution board with that cage coming through might be a little risky. So I'm liking more the
Just having it here.
yeah, and the big empty spot there. It might be a lot simpler.
Can you put the Robo Rio there?
Yeah.
I mean, you could put the Robo Rio there too if you've got space.
Mm-hmm.
Yep.
Anyway.
I also need to work on the coral holder here. I've tried to have some people help, but no, they haven't really done much. So hopefully I can get that done by the Saturday.
It's pretty minimal. I don't think that's key priority right now.
Hmm.
Let's really get the PDH. Let's make sure all the major structure stuff is in place. That little stuff we can just kind of prototype and test something that works the way we like it. Do we want to switch to programming, or do you have any more CAD discussions you want to talk about?
Um, I guess not really. Other than like, how is there a way to make this more rigid? I know Carl mentioned something about making the yellow tube turned like 90 degrees. Let me get a better view of it.
I think we're gonna just have to test what we've built already, Cedric.
Okay.
We might have to make some changes and just test something that might work better, and then once we have a better idea of how to fix it, then we can update the CAD.
Okay. That's fine.
It also might just be an issue with how we built it, right? If we figure out
Yeah.
what the problem was and we just need to improve it, that it might be something really simple like adding a spacer or something somewhere. So.
Okay. I think that's all I got.
Okay, I think you're getting close. Just stick with it. I know it's a lot of little stuff, but don't be discouraged. I think you're really close. Just keep thinking about all these little details and get them all resolved, and then we shouldn't have to do much afterwards, right? If it all works right. So.
Yep.